rotate button before. Not that hard to erase. Bye-bye. So since we already talked about GCF, these problems are a different factoring technique. Let's go ahead and talk about GCF. And if you look out here underneath the practice, you will see at the bottom of the page that I've worked through many of these problems. Problem number 1, 713, problem 2, problem 3, problem 4. For some reason, I put problem 3 on there again, problem 10, and my computer's oh, there it is, 11, 12. So I'm going to try to pick problems that I don't already have a video for. So let's start. Let me see. I already have those 3. So let's start with problem number 13. Problem number 13 is not a good problem to start with. I just noticed that. Let's do 14. So here's how we do factoring by GCF. I look at this and I see 2 and 10. And you might be thinking to yourself, I know what goes into 2 and 10, that'd be 2. And you would be correct. So when I think about 2, I got 2. And for 10, this is 2 times 5. Okay. Now on the x squared, that'd be x and x. And for just the x, it'd be x. So all I did, and you don't have to do it this way, is I broke this up into factors. Okay, so 2x squared is 2xx, and then 10 is 2 times 5. So when I look at this and I'm trying to find what does this have in common, I could say they both have a 2. So I factor that out. What else do they have in common? They both have an x. So I factor that out. And then I'm looking, I circled 2, I circled an x, but they both don't have a 5, and they both don't have another x. Now, if I had circled 2 x's, instead of putting x and x, I'd put x squared. Inside, I put down what's left over. I already circled that. I already circled that. I did not circle that, so that'd be x. Bring down my operator as a minus. And then I did not circle 5. Now, how do you check your work? There's a couple ways. One, you got to make sure that nothing inside has anything in common. X and 5, all they have in common is 1. 1 goes in X, 1 goes into 5. We don't really care about that. But one way you could really check your work is if you go to Desmos and I type in 2x squared minus 10x. That's what we call a parabola. Okay, it's in standard form. Now, when I plot this, this is called intercept form, and you'll see that they're the same thing. They should be the same thing. And notice they are. Blue and red are the same thing. So that's one way I would encourage you to check your work as you go. Those are very clearly the same function. All right, number 15. We could start off and then we could finish it. When I look at this, I see 7 and an x and an x. That's for 7x squared. For 14, I could break that into 7 times 2 and an x. And I'll move the x over so it's more clear. And then 56, I could break that into 7 times 8. And so when I'm looking for common factors, I look, and the only thing this has is a 7. So I have a 7, I have a 7, I have a 7. The 7 must be in all 3 to be called a common factor. So let's pull 7 out. I got a 7, 7, and a 7. So I have a 7 come out. Now let's see if I could circle anything else. Or is 7 the greatest common factor? There's nothing else with 7. So There's no way I could circle 2 or 8 because all this is 7. Here I have an x, no x. So I cannot circle x. So 7 is what we call the greatest common factor. This is the GCF. It's the greatest. Here we call 2x the GCF, the greatest common factor. And what we mean by greatest is, yes, 2 is a factor. Yes, x is a factor, common factor. But what's the greatest? 2x. What's the greatest here? 7. So what do I have left over? I have already circled that, x and x, that makes x squared. Bring down my operator of minus. I did not circle 2 or an x. And I did not circle 8 with an operator of minus. Now, when I look at this, I have x squared, 2x, and 8. There is nothing in common between those three besides 1. Just to practice checking my work, I'm going to type this in. This is called standard form. 7x squared minus 14x minus 56. 7x squared minus 14x minus 56 looks like this. And then if I type this in, I should get the same thing. 7x squared minus 2x minus 8. Looky there. They're the same thing. Now, this one's technically not finished. Anytime we have an x squared left, we try to factor it more. And so I'm going to show you a new technique. And this is how the new technique works. What we're going to do is we are going to now factor this part. Okay, so how do you do that? You make the factor x. This number comes here. So that's going to become negative 8. And then this number is going to go on the bottom and make negative 2. You can only use this factoring technique when a is 1 or negative 1, and we try to make that 1 first. And there's 1, 2, 3 terms, and this is a 2. So it's a quadratic. What I'm looking for 2 numbers that multiply to negative 8, but add to negative 2. So what multiplies to negative 8? Let's see, what about 1 times negative 8? 1 times negative 8 is negative 8, but 1 plus negative 8 is negative 7. That doesn't work. Okay, so 1, always start with 1. Let's try the next number. Let's try 2. 2 times negative 4 is negative 8. 2 times negative 4 is negative 8. 2 plus negative 4 is negative 2. So those are my 2 special numbers, 2 and negative 4. So what we're going to do is we're going to pull down the 7. And we're going to take this x squared and break it up into 2 linear factors of x. And then we're just going to drop the 2 as a plus 2. And we're going to drop the negative 4 as a negative 4. Okay, so all I did was I brought down the 7 because that's still the GCF. I took the x squared broken into x and x, and I took these 2 numbers I found and put them on the sides. Now this is what we call intercept form. We're going to be learning more about this next week. Basically, this tells us the x-intercepts. I know looking at this, the x-intercept's negative 2. I know looking at this, the x-intercept's 4. And I'm going to type it in so you can see that they are the same thing. Oh, x plus 2x minus 4. I typed it in wrong. Ah, they're the same thing. So this is called standard form. This is what we would call factored, but not all the way. So in your practice, you'll see something called factor completely. That means that if you stop at this step, you're not technically done. This one is the best form, I think. As I can see, my x-intercept's -2. Looky there. X-intercept's -2. And my x-intercept is 4. Looky here, 4. So I like this form a lot. And then there's another form we're not going to learn today that will tell you the vertex right here. Okay. But most of the time, when someone gives you a quadratic, it's written in standard form. And all this tells me is that the y-intercept's -56. If I go way down here, the y-intercept is -56. That's all I get from that, besides the fact that it opens up. Okay. So I've shown 2 GCF problems. I will show 5 and 6, and then I'll call it good. 5. We do not like negatives out front. They're hard to work with. So to get rid of the negative, we just factor it out. So when you divide by a negative, that just changes everything. So that changes that to a positive x squared. That changes that from a plus to a negative. And that changes that from a negative to a positive. So it negates everything. So anytime you have a negative, just pull it out. Not that bad. Now from here, I need to start writing a little smaller if this is going to fit. I put the 55 on top. That goes here, and the -16 down here. And then I start playing with the numbers. And sometimes this doesn't factor. Sometimes there aren't 2 numbers that multiply to 55 but add to -16. Let's start off with 1. 1 times 55 is 55. But if you take 1 plus 55, you get 56. That's not going to work. The only way to get a negative would be as if both of these were negative. Okay, because negative times negative is positive, and negative plus negative is negative. So -1 and -55 multiplied together is positive 55, but -1 plus -55 is -56. So that's not going to work. So 1 doesn't go in, 1 doesn't work. 2, let's try 2. 2 does not go into 55. Okay, if you type 55 divided by 2 in your calculator, you get 27.5. We don't work with decimals when we're factoring. So 2 is not going to work. Let's try 3. 3. 55 divided by -3 is -18.333. So -3 doesn't work. Let's try 4. 55 divided by -4 is -13.75. That does not work. So this is one of those things that if you're good with your multiplication tables, it becomes much easier. Like, let's try 5. I know that -5 times -11 is plus 55. But if I add those, I get -16. So those are my special numbers, -5 and -11. So I pull down my negative. And because this is x squared, it is not always x. Sometimes we use y, sometimes we use a's. We're going to break that into 2 x's. And we're going to pull down our 2 special numbers, which was -5 and negative 11. Checking our work. If I type this in, and this in, I'll get the same thing. Now, how is this different? That negative, we talked about transformations. The negative is going to flip it over. So it's going to look like this, a U-shaped upside down. It doesn't hurt to type it in. Negative x squared plus 16x minus 55. And all I know is the y-intercept's negative 55, right there. And notice it's opening down. We call this opening down. So it's increasing, 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 increasing. Then it's changing direction and then going down. And this goes down forever on both sides. So let me type in the first thing I think. Negative x squared. This is also a way to check your work as you go. Plus 6, so I had x squared minus 16x plus 55. Notice they're the same thing. Same thing. So this is partially factored, and then we factored it even more, and we got negative x minus 5x minus 11. Negative x minus 5x minus 11. And notice they're all the same thing. The only thing nice about this form, the negative, it still opens down. We know that an x-intercept is at 5 and at 11. And I know this may not look like 5 and 11, but I'm way zoomed out. So if I zoom in a little bit, you'll see it's 5 and 11. How cool is that? It comes straight from there. Okay. My last problem is going to be number 6. There's not a negative. So I take this number over here, this number, and I put that on top. And I'm going to use a little bit smaller, maybe zoom in a little to give myself more space. So that's just going to go on top. Your constant always goes on top. Now on bottom will be this number 2. And I'm going to put that down here. I'm looking for 2 numbers that multiply to negative 48, but add to 2. Well, let's try. To get a negative, 1 must be negative. So let's do negative 1 and 48. That multiplies to negative 48, but when you add them, you get 47. So at least I have the negative in the right side. If I had got negative 47, I'd move the negative over. So I know the negative is probably going to go over here. That doesn't work. That adds up to 47. Try again. Let's try negative 2. Negative 2 times 24 is negative 48. I add those and I get 22. At least I'm getting closer. That doesn't work though. Let's try 3. Let me think. Negative 3 times 16 is negative 48. Add those, you get 13. That is not 2. So let's try again. And again, the better you are at your multiplication tables, the easier this is. I can't remember what number I was on. I think it was 4. Negative 48 divided by 4 is negative 12, or 12, I'm sorry. Positive 12. I should know that one off the top of my head. But 12 and negative 4 is 8. I'm getting really close. Let's try 5. 5 doesn't go into 48. 6. Let me think. 6 go into 48? Yeah, that's 8. -6 and 8. And as soon as these numbers are super close, that means that you're just going to end up repeating the opposite. So once these are about the same, you can kind of stop. But luckily, -6 plus 8 is 2. So those are my special numbers. So on this one, I would say, okay, x minus 6 and x plus 8. And I can see the x-intercept is 6, and the x-intercept is -8. Okay, so I've worked through a few problems for you. If you get stuck, please remember I have video after video out there of me going through the different problems. Good luck. There's 2 skills. I'll use this page. 2 skills we talked about is how do you factor when this number is a 1 or a 1 or even a -1. And there's 1, 2, 3 terms quadratic. 1, 2, 3 terms quadratic because of the 2. 1, 2, 3 terms quadratic because of the 2. And the way you factor those is with the x. And that's with 1 through 9. Then here we focus on GCF. So we look at this and we try to factor something out first. And then if whatever we get here is in this form, then we go ahead and factor it again. Okay, so here's an example where we factored out the GCF and we got x minus 5, which is not in this form. We don't have a square and we don't have 3 terms. So that's why we stopped. Whereas this one had a square in 3 terms, and I was able to factor it some more. Now, before you start, not everything factors. So it could be that you have to stop at this step. So be careful. But other than that, that's all I have. Hope you have a great day. Hope you find this video helpful, and it was nice seeing everyone. All right, bye-bye.